Now, when we refer to properties of a substance in a system, we imply that value of the property has significance for the entire system. That is, when we prescribe a temperature and pressure value, that value is going to define our state, and thus it's going to define the behavior of our system. And thus, this implies equilibrium. If we are in thermal equilibrium, the temperature is the same throughout our entire system, and therefore we can speak of temperature as a property. If we are in mechanical equilibrium, the pressure is uniform throughout our system, and therefore pressure is a property. The system is in thermodynamic equilibrium when it is in equilibrium regarding all possible changes of state: thermal, mechanical, and chemical. Now, whenever at least one property of the system has changed, whether it's temperature or pressure, a change in state has occurred. The path of succession of states through which our system passes is denoted as a process. And processes are denoted by letters A, B, C, etc. Now, to provide properties at each state, the system has to be in equilibrium. Now, if we are changing, we are going to assume the transition from one state to another is done in a quasi-equilibrium process. That is, if we look at intermediate states, each of those intermediate states is existing in thermodynamic equilibrium. When a system in a given initial state goes through a number of different changes and returns to its initial state, the system has undergone a cycle. Now, there are three common processes that can exist. The first is an isobaric process, where our pressure is remaining constant. If we look at the PV diagram below, if we go from state 1 to state 2 in a constant pressure process, this would be an isobaric process. An isochoric process is where our volume is invariant during our change of state, and this would be represented as going from state 3 to 4 via process B. An isothermal process is where our temperature is constant during our change of state, and this would be going from state 5 to 6 via C. A cycle is a series of processes that progresses from initial state through various intermediate states and then returns to our initial state. Let us consider the idealized diesel cycle below. Our PV diagram shows us going from state 1 to state 2 via an isothermal process. Then we go from state 2 to state 3 via an isobaric process. Then we go from state 3 to state 4 via an isothermal process. And then we go from state 4 to 1, our initial state, via an isochoric process. Now, given the following PV diagram for an idealized Otto cycle, we want to identify each of the processes. Process A is going from state 2 to state 3, and this is an isochoric process. Process B, going from state 3 to 4, is an isothermal process. Process C, which is going from state 4 to state 1, is an isochoric process. And process D, going from state 1 to state 2, is an isothermal process. And we see the Otto cycle is a cycle. That is, we go from state 1 to 2, 2 to 3, 3 to 4, and 4 back to 1.